mySociety is one of the most wonderful things to come out of the bottom-up democratic movement in the UK, and the UK is a shining light for the rest of the world. I mean, it is magnificent what's done, and I've used many of the tools of mySociety. I've used Write to Them on many occasions. So how many people have used Write to Them? Hey, wow! But it just makes the whole business of contacting your representative so much easier. And I've also used a lot of What Do They Know, FOI requests, and again, it's absolutely brilliant. It makes a difference between doing it and not doing it. It doesn't always mean you get a reply, and we actually need an automatic bot that beats up the people who think that by not replying they're helping keep the noise level down. I have been a scientist in Cambridge for 14 years, something like that. I've been in the chemistry department. I'm still part of the chemistry department, but I'm technically retired. I have found that in the last few years I cannot do my research because I'm being prevented by things which are not scientific, but which bring me right up against the problem of ownership of property, of intellectual property, of regressive, restrictive practices, and so on. So half my work has been fighting against the mega corporations to try and get justice in terms of our right to access and reuse information. So a year ago I applied for a fellowship with the Shuttleworth Foundation. That's this is Shuttleworth, this is Jack the Baboon from South Africa. How many of you use Ubuntu? Right, well, Ubuntu was developed by Mark Shuttleworth. He made a lot of money out of it, and he's put some of the money to support people like me. Fellows are required to change the world, and that's what I am in the process of doing. And another very well-known Shuttleworth Fellow is Rufus Pollock, who set up the Open Knowledge Foundation, and I'm very happy to discuss with any of you how that works. So, my reapplication is due in tomorrow, and for that they need a 5-minute video. It's probably the easiest way of explaining what I'm doing. So I'm going to play this video. I'm Peter Murray Rust, and this is my application for a second year of Shuttleworth Fellowship. Here's PMR presenting the vision at WIKIMANIA this year. So, I'm going to talk about Content Mine, which is a project which is funded by the Shuttleworth Foundation, which has given me the opportunity to build something completely new and different. So we are going to use machines to liberate scientific facts on a massive scale, and we're going to put them in Wikidata. We've created a great team over the last year, and they'll tell you their roles.
Hi there, my name is Ross Mounts. We're here to analyse PLOS, BMC, PeerJ, eLife and the Hargreaves Allowed corpus.
Articles contain facts. They also may have associated supplementary materials. A journal contains many articles. Some journals publish a vast number of articles. There are many journals, many of which have restrictions. So at the end of the day, there are billions of facts trapped in a galaxy of articles.
We've tried this out on many people in our workshops, and they've gone through, and you can see how they've marked up different things with different colours. And that's what we're going to ask the machine to do. So here's a machine. This is how a machine might see a bit of science. You don't need to understand this, but you can see the different things that a machine might be able to pick up. And we can mine data as well. Every bit of information in this image has been extracted and can be further manipulated. Richard and the rest of the team have a generic solution.
We've built an ecosystem of open source software for data mining the entire academic literature, and we've also grown a community of volunteers who help us maintain it. And now we're actually ready to go live and start doing content mining on a daily basis on a massive scale.
We start with the scientific literature, we crawl it, we scrape it, we extract it, and then we're going to take the results and put it in Wikidata. And what we need is we need more science plugins. So I've written a chemistry one, I've written a phylogenetic tree one. We need people to do maps, we need people to do birds, we need people to do stars. This is our application software. This is what we've been concentrating on at the moment and what we're immediately going to do. It's based on a plugin architecture, so that every discipline can create a plugin specifically for its needs. We need to spread the word and train people, and Jenny tells us how.
It's historically been very difficult to use content mining technologies, which has led to a huge skills deficit. We're trying to address this by running international workshops and also creating a repository of open online materials so that anyone researching anywhere in the world can find out how to do content mining.
Jenny and Puneet have just run a workshop in New Delhi.
Quick scrape has been really interesting. I was wondering if you have any way, the way you have the AMI species functioning going on, is it possible to have, let's say I'm interested in 100 papers.
Yes, we're already doing literature research on the variety of plants and the chemicals they produce. STEPH explains our resources.
As part of our commitment to remaining open, we're creating a modular resource base for teaching and learning content mining so that we can make sure that our project is accessible to wider audiences.
Here's what we've already achieved. We've run several workshops. We're collaborating with a lot of different organisations and people. We're working with publishers. We've applied for grants, and we've already got several publications. We assert that the right to read is the right to mine. We're starting the daily extraction right now. PLOS One, then BMC, then PeerJ, and then moving on to the closed journals, which is now legal in UK. So to sum up, we're going to start extracting facts now and grow this rapidly month by month. We're going to develop more workshops and train people to do the workshops by themselves. We're also going to create a community of developers and scientists so that they'll decide what can be done and build the tools and the protocols to run that. And finally, we're going to look and see how content mine can become self-sustaining. So, we're going to liberate 100 million facts a year from the scientific literature. And we're going to put them in Wikipedia, or rather Wikidata. And we're working closely with Wikidata. By the way, everybody is welcome to, this is my promise, I will never sell out to non-transparent organisations. Because what's happening in this space is as soon as somebody in academia comes up with a bright idea, they then go and sell themselves to either digital science or Elsevier. And this is a major problem because all the innovation gets bought up and killed. Skip. Okay, so this is my thesis, that publicly funded research, including charity-funded research, is about $400,000 million a year, or 400 billion, if you like that. I don't have an exact measure, but it's an awful lot of money, and you are all paying for it. And there are about 1,500 scientific articles published each year, so each of them represents about $300,000 of work. And if you want to publish, how many people here have published a scientific paper? Right, the majority of it. It costs somebody $7,000 to publish that. It either costs your library to subscribe to it, or you have to pay fees to the publisher, or both. And at the end of that, you might be able to access the paper. It technically costs $7. How many of you have used Archive, ARXIV? This is physics and maths, and the cost of putting a paper that the world can read is $7. So we have a vast scale up here. Some of that is due to the fact that academics want glory, and this is the price that you have to pay for glory, that to get it in a journal like Nature, 95% of the papers are rejected, and that's where some of the cost comes in. But the cost is also the fact that Elsevier make profits of 40%. No other industry makes that amount of profits because they get the stuff for free and they can charge what they like because they're a monopoly. You can see I have a slight take on this. And academic libraries spent $10 billion a year on this. And almost everybody in the world cannot read this. It's only rich places like the University of Cambridge and Harvard and so on which can actually read most of the scientific literature. Now, we are therefore denying ourselves a downstream wealth. And Battelle did a study on the human genome. $4 billion were invested in it, and they calculated that we got 800 billion, this is in the US, in terms of jobs, in terms of materials, new technology, and so on. So a huge multiplier effect. Now, here's the bad bit. Most of that published science is wasted. So the Lancet 4 years ago suggested that 85% of the research was wasted because it was duplicated, it was badly designed, it was poorly reported, it just wasn't published at all, things of that sort. And PLOS have confirmed the same thing this year. The way it's published is awful. How many of you have tried to read the words in a PDF? Not with your eyes, but with a machine. Right, that's what we're on about. PDF destroys information more than almost any other thing, except I had a paper which I've just published. They said, oh, please can you actually photograph the maths equations in this so that we can embed them in the HTML? I mean, and this organisation described as a 21st century dynamic publisher. I mean, it is awful. So we need to turn this stuff into semantic form. Right. Here's the Vice-Chancellor. This is not me ranting. He was asked 2 months ago by Michel Brook about spending money with Elsevier. Just wait until we get into open data debates. Elsevier is already looking at ways in which it can control open data as a private company. And that is true. The point is that these publishers are so big that libraries will have no ability, no communal will to do anything other than pay them money for their products. And in this way, we get the same effect as Google, Facebook, and all the others who build up a restricted walled garden environment. We've tried to change that. So we have argued that the right to read is the right to mine, which is what I have here. And the publishers are trying to make us license quotes their content so that they can restrict our use of it. And we've fought it in Brussels, and it came to a showdown, and basically all the good guys walked out. Are there any publishers here? Okay.
I'm an ex-publisher.
You're ex-publisher. Okay. Well, you will feel.
I will admit it now.
You will feel a bit of angst in this. So that they came up with a license for Europe, and basically that's an impasse. Now the great news is that UK has jumped ahead of everybody else, and we'll see that in a minute. This is typical. So this came out this was this year's Ebola hemorrhagic fever. A report on this. If you want to read it, you have to pay $31. Now that's a crime against the planet. But academics don't care. So long as they get the glory of publishing in the Lancet, that is all that matters to them. I've been an academic, I'm allowed to criticise them. Okay, so this is the Open Access Declaration, and you can see here the learning of the rich with the poor, and the poor with the rich. That's the important thing. True open access is democratic and symmetric. It is not about little bits coming out under publisher conditions. It's actually about building the same ethos that open source has built. Right, so you didn't get this in the video. I have to find out what's wrong. I think the poor machine can't drive the speakers and the projector and think at the same time. I think that's what the problem is. So this is our phrase. I've created this phrase about 3 years ago, and it's spreading. That is that if you have the right to read a piece of information, you have the right to data mine it. So it's crawling. How many people have written a crawler here? Right. Is it fun? No. So,
Yeah.
what? Does it still work a year later?
Sometimes.
Exactly. How many people have written a scraper? Right, and by scraping we mean something that looks at a URL, in this case a scientific paper, and pulls down all the bits, the PDF, the HTML, the pings and everything. And then we have to extract the facts. So how many people have written a PDF parser? We'll move on. My thesis is that actually citizens can understand science if we translate them for it. So nobody here knows what Panther and Leo is. Well, I'm sure they do actually. But everybody knows what a lion is. And similarly, you might not know what Aspergillus oryzae is, but it's the fungus that makes soybean sauce. So these papers actually become accessible if you build a semantic amanuensis into it. Amanuensis is a scholarly assistant. So here's our amanuensis. She's called Amy. She has no emotions. She does what she's told. She never gets bored. But if you tell her something stupid, she does something stupid. And that's what most programs do. So we gave this to people who knew no science whatever, and you can see that they've gone through and marked this up, and they've done a very good job of it. Similarly, our machines can do this, and we use here some quite sophisticated parsing. This is a shallow parser, which we turn the chemistry here into a Chomsky-like parse. In chemistry, we can take this. How many chemists here? None. Good. Well, this looks like gobbledygook. But the machine, our software, the machine can read that, and they can actually turn that bit of language into actual living chemicals. These are semantic chemicals, and it works it out within a second. So we can read the literature in that way. So this is our pipeline, and the way we're doing it is we are exposing a plugin so that people can add in plugins for the scrapers. Richard was going to be here, but he isn't, so that was Richard on the video, and he's built all this stuff, and he's got lots of volunteers to do this scraping. And similarly, I'm beginning to get people who want to scrape chemistry and species and things like that. And we can actually now take PDFs, and we can take that PDF here, that graph, and we can turn it into a CSV file in less than a second. So if you have graphs that you want to read, then our technology, I mean, it needs customizing and it needs blood and sweat, but ultimately you can get to a stage where you can turn that into that. And this little picture here shows it. So it's got units and scales and things like that. And these don't have to be science, they could be stock prices or the number of amount of money spent on drugs against the amount of people who still use drugs. You all saw that in the last few days, right? Okay. So it would parse that sort of graph. Then you've got that, and then you can do clever things like smoothing it or looking for the variations. We're working particularly on phylogenetics, so this is published, every new bacterium comes out in this journal, the International Journal of Systematic Evolutionary Microbiology, that's it. And we're now, even though it's a closed journal, we're now extracting it under the new legislation. I think I've finished that bit. I might just go back and see if we can find Professor Hargreaves on the video. No, I'll tell it in words. What's happened this year is that the UK government has pushed through copyright reform, and it has given exemptions or exceptions to copyright, which now allow you to do 5 different things. One of them is parody. Does anyone here write parody? Well, if you do, then you will not be sued for copyright, or you can defend yourself in the UK. You might be sued for something else, right? And so on, but you will not be sued for that. Similarly, you can do format shifting, archiving, and most importantly for us, we can do what's called data analytics, or as we call it, content mining. So that I will get to this one, which is quite fun. This is mining scientific images. So this gives us an idea of some of the things that we can do. You've seen that one already. But we can take a picture like that. That's snapped with my iPhone. And we can turn it into a chemical formula. And again, that takes about a second. So if anyone's interested, has anyone done any image analysis? Good, I'd like to talk to you, because we can now do scientific image analysis. We can recognize that structure and turn it into a chemical. Here's a whole lot of chemicals, and my colleague Andy Howlett can read the whole of that and turn it into an animated reaction. All of that within a few seconds. So we can read the whole literature. There's another one that he can do. He can read the whole of this there automatically and turn it into animated structure. And you see this stuff here. So I'll finish the slides there and say that what's at stake is the following. We can take, literally, there are about 1,000 new papers come out a day. We're building a crawler which is going to extract all these papers from the journals that we are entitled to read in Cambridge University. And this is why we have to have our magic jumper on that says Cambridge University, because that allows us to read it in Cambridge. How many people, by the way, have access to Cambridge? Yeah. Well, okay. Well, if any of you want access to this, if you become a research collaborator of me, then you can get access, right? Right. I am not in it for the glory. I am in it to destabilise, disrupt the whole system. So I am allowed to collaborate with anybody. So if you've got research projects, you want to mine the literature, I can do it. And so long as we don't sell the results, then that's fine. We can do it for non-commercial purposes. And we have to be British, which is why we have the British flag. We're allowed to do it in Britain.
So can I ask you a quick question there? So when you say you can do it for non-commercial purposes, does that mean that all of the things that you put out here have to be under a non-commercial licence?
Good question. Let's come to that in a minute.
Okay.
No, literally, I'm just finishing up. So the position is the publishers have fought this with mud and FUD and money and suits and lobbying and so on. It's very difficult doing your research when you know that there are people out there with literally millions of dollars trying to stop you doing your research. So that's the situation. We've got the law hasn't been tested. I am allowed to do it, according to the law, for non-commercial purposes. Elsevier says I can't because they can stop me doing it under the law. And we had a big public fight in London, verbal, with Elsevier, and we won on points on that one because they've sort of said, well, maybe okay. Springer are actually okay on this. So our view is that we can extract all the facts in a paper, and we can also surround them with 200 characters of context. Now that gives you enormous power. So the publishers hate this. They want to get the libraries to sign these rights away. So they're trying to persuade libraries to buy special text mining services whose purpose is to stop me using them, right? And when I say me, they do quote me by name because they say, well, if Peter Murray Russ does this, he's going to melt our servers down. They say, there's no demand for this, for text mining, but if Peter Murray Russ does it, then our servers will be melted, right, okay. So, has anybody been in a FUD fight with a large corporation? No one's fought Microsoft. Is there anyone from Microsoft here? Right, okay. Well, I have a friend in Shuttleworth who's fought Microsoft. At one stage I took money from Microsoft. So the point is that, if we take this title, that's what's called an entity, and everything here could be regarded as the context that established the facts. So now let's go into the discussion. Coming back to what you asked, it's untested in court. We're going to put this out not as a resource, but because I'm a responsible scientist, I have to publish all my research data. So if I mine all this stuff from the literature, as a research scientist, I have to make sure the rest of the world can see what I'm doing. So I will put it out under CC0, which means anybody can do whatever they like, and if they want to commercialise it, their problem, not mine. So that's the position at the moment. And we're going live today. Again, I'd hoped Richard was going to be here, but we have sort of switched it on real soon now, and it might be now and it might be tomorrow, but it's that sort of timescale of things. So we're not getting the 1,000 articles, we're going to do PLOS, which is a primarily biological journal, and do that one. So I'll stop talking and invite questions and comments and so on.
What do you mean by fact in this context? The reason I ask is I would expect that when you do mining, you kind of go in, you set the mining up with particular sorts of information that you want out, and it would be very hard to say, actually I'm going to extract everything that might be of any use to anyone.
Right, so I don't say that. I say that I'm researching into a whole lot of fields in which I'm now a world expert, right? I'm going to try and find, it was in the other paper. I'm trying to find a paper here somewhere or other, so you could see it. I don't know whether... I was doing this one, wasn't it? No. Okay, let's try one more here so that I can... So a fact is not copyrightable. So that's why I use the word fact.
Right.
That means I cannot be prosecuted for copyright violation if I extract facts, and the court will decide.
But a fact might be something like such and such a compound is contraindicated for such and such a medical condition, or something like that.
If that's stated as a fact in the paper, then it's a fact, in my view.
Right.
And I don't have to agree it with you, I have to agree it with Elsevier's lawyers. That's the problem.
Well, and you have to have some understanding of what the people who want to use these facts.
Okay, let me get away from the legal side. I would now say that anything that can be represented by a named entity is part of a fact, and generally a fact is something which can be represented by an RDF triple. So in other words, the melting point of X was something, that's a fact. The dimensions of the mass of this projector is 3 kilograms and its length is that, and so forth. That's my intention of facts. So it contains numeric quantities. We'll go back to this one. My Wikidata, so we'll skim through this until we come to a bit of paper and so on. Yeah, so here's a bit of paper there. This thing was actually unreadable. Yeah, here you are. So I would say that Western Central Africa is an entity. Late Pleistocene is an entity. East Africa, Middle East, mitochondrial. These are entities, and therefore we can expose them. In some cases we can turn them into RDF triples. In some case, we'll simply expose the entity and say this entity occurred in this paper.
Yeah.
Which is a fact in itself.
Exactly.
Yeah.
It's an index. So an index is a set of facts.
You touched on the question of quality in one of your earlier slides, and a lot of the progress of science is actually in the dispute and refutation of facts, or in the modern world in just the silent failure to replicate. When a scientist is looking at these scientific papers, they're making judgments in as best as they can about which of these labs produce data that is accurate and valuable and which don't. In a content extraction framework, do you have thoughts about maintaining that sense of quality of facts and actually being able to update statements and facts with low or high measures of confidence?
Okay, so here's a chemical synthesis, right? You can't read all of it, but it says to a solution of that was added something or other. We can parse this 100% into a semantic form, right? Because it's so formulaically written. And I would contend that that paragraph as it stands is a fact, right? Now, whether it is a correct fact is not our concern. That is a fact which is published in this journal, and if people want to search it for that, they can find it. Other people can then use it and say, well, actually, DMAP doesn't dissolve in THF or whatever, and so forth. But this is a statement of what the authors reported as a fact.
But I think if you kind of take aside the battling of the multi-million-dollar corporation, assume we've done all that and we have our framework and we're starting to use it, I think tracing back to the whole context is going to be really important for people who are going to want to use these facts. It's a bit like the subprime loan repackaging. If you repackage and extract and you don't keep that, you lose the sense of whether this is a good fact or a bad fact.
Absolutely. So this will have all the metadata in it, which links to the both to the entities. So in other words, what THF is, where it is. By the way, we're taking all our data from Wikipedia by default. So wherever possible, we will link to Wikipedia because it's one of the most actively curated resources anywhere. So if they want to know what this didn't actually have DMAP. Well, brine, for example, that will link back to Wikipedia. I think I'll go backwards. Yes, so these things, dimethylformamide, that will link back to Wikipedia and so on. So you will then, that's the best guess. You don't know that what these people had in their bottle, and nobody ever will actually know what's in their bottle in the lab. You know, you can't, it's not a mathematical proof, but you will be able to. This will then link to the DOI of the article and will allow you to search backwards and forwards through the literature. We've done that, for example, with Wakeman's paper on MMR. Yeah. And you can actually see which papers quote it and which papers quote that and so on. And it's well known that the more, the longer the chain of statements about a paper, the more factual it becomes. So A might say, B might say, A hypothesized that DMAP might dissolve in THF. C will say, B used A's observation that TMAP dissolved in PDF, and D will say TMAP now dissolves in PDF. That's very well known.
And I think that'd be a fascinating kind of structure to
Absolutely.
build into this kind of work, because it is who said and what kind of quality of reputation do they have for being correct and being thorough.
So the whole point is to open this up so that anybody can do this work, because at the moment nobody can do it. And the publishers aren't doing it, although they're throwing money. I mean, Elsevier has bought up UCL, as you probably know, so nobody in UCL will be allowed to challenge Elsevier and so forth. And they clamp it down. They have their view of how they're going to run this to make money, and it allows no innovation of the sort that you were.
To what extent are you able to determine that there's an indirection involved? I mean, I'm thinking of a a sentence in a scientific paper like 70% of West Africans believe that Ebola is a conspiracy by the Americans. If you pick out of that Ebola is a conspiracy by the Americans and present it as a fact, can you, how far back from that do you...
So this is what natural language processing calls sentiment analysis, and it's hard. There are a number of statements about statements which are very difficult to pull out. You'll get different types of facts in the introduction, in the methods, in the results, and in the discussion. So we separate this. So if somebody in the paper says in the introduction, Ebola has been described as a product, whatever you said, right? Quote one. That was it. In the discussion, it might say, we now hypothesize that Ebola is a real virus and not something or other, right? And that's a hypothesis, which doesn't mean it's a fact, but then somebody else will report that hypothesis. You've also got things like, we could find no evidence for X's claim that something. We're not going to do that sort of thing. We're going to take the things which can be represented here as, if anything comes out of the results like this, then as far as we're concerned, it's a fact and it can be...
Yeah. You really are looking at triples rather than at quadruples.
In terms of statements about statements, yes. I think in terms of provenance, we'll keep the provenance. And of course, some things are more complex than a triple. So, I've developed with Henry Jepper a chemical markup language which holds chemistry as XML objects and so forth. So, you put it into objects where that makes sense. You don't try and hold all the letters on here.
To what extent do you allow or facilitate human feedback on your so-called
Excellent question. Extremely, right? So this is a social machine, right? This is not a machine which is telling you what's in the literature. Its prime, so one of its purposes is to be disruptive, as I've said. What we plan to do is every day we plan to put out a stream of the facts that we pull out of this. How those are used will depend on the community. So we don't know how this is going to play out. So for example, I'm talking today at the Cavendish, and we might, for example, find all papers which mention exoplanets. I mean, part of this will just be an index. So you get, read the paper every day. How many papers have come out which talk about exoplanets? How many papers talk about Ebola, Marburg, hemorrhagic viral fever, and so forth? And then I hope that we will find people say, oh, well, this is really exciting. I'm finding that, papers co-report. I'll go back to the phytochemistry, species which, that marsupials are correlated with this type of terpenoid or something of that sort. And then they will pull out those connections there. Now, I think that what we will do is produce a daily stream of facts. We're not going to archive this because we can't, it's just too big. But we do believe that a daily stream of facts filtered on whatever anybody wants will be enough to put out to the world. So you'll get this stream, and if you're interested in things, then you can capture it. So who do you think are the people who are most interested in binomial Latin names of dinosaurs?
Children.
Exactly.
Absolutely. That's what I was about to say. It's for 8-year-old boys. Yeah.
Exactly. Well, I've had as low as 5 years. So we're going to put out the daily binomial dinosaur. And they can do whatever. They might want to play dinosaur bingo, or they might want to, so whenever a new one comes out, they can get it before their friends get it or whatever. I have no idea.
What's the URL for that?
Well, our URL is contentmind.org, and I met up with somebody at WIKIMANIA, MozFest, who does stage 1 and key stage 1 and 2 kids, and we're going to flood the dinosaurs out to them. So
you see the pizza has arrived.
I can see that. I can smell it as well.
Yeah, I know.
So don't let me stop you. But I would love to have people who want to come up with ideas. We're literally, as I say, going live today, and also people who who are interested in developing hacky tools on this, scrapers or extractors, people with a specific discipline interest, or people who actually want to challenge mega corporations.
Can we make a daily mail?
Help yourself to pizza and more beers.